All right, this is going to be a review of this Atwood homework here. So I'm going to go through each one of these problems and hopefully we'll make some sense of it and uh, you'll know it better by the time we're done. Okay, so this first question is a pulley system where we have one object having a mass of 3 times m and the other having 2 times n. And so we're going to do that. So similar to other problems we've done, but I'll go through this problem first, and then uh, we'll I'll do it kind of more generically, and then we'll use that information to help us with number 2, just to try to reformulate it, and then we'll go from there. All right, so you'll see. All right, so that is very small. All right, so let's move in here. Okay, so just as we've said before, we start off with a problem like this, and we can draw in our vectors first. So that's a good place to start. So this is going to be a force of gravity down, and that is going to be equal to 3 mg, because gravity would just be equal to mg. All right, and we could label this as, block 1 or whatever, but in very short order here. In fact, even right now, I'm just going to get rid of this, and we'll just define that force in this particular way, and so we won't have to worry about that anymore. Okay, and so this is experiencing a force down of 2 mg. That's for sure. But why aren't either one of these blocks falling? Well, it's because there is a force of tension up that they are both experiencing, so forces like this. And we don't need subscripts on these tensions because they are the same for each one of these blocks. All right, so beyond this, it becomes difficult to determine which object is moving to the right and which object is moving to the left. So what we do from here is we kind of imagine like we swing these out as if they're moving on a single plane. And that allows us to better analyze the direction and kind of make sense of the whole thing as a system. Uh, it's not a requirement, but again, it's one of those like useful sort of things to do. So this is 3m and this is m, and then I just transpose those vectors here. We have our tension in this one and our tension in here. And then this is our force this way, which is 3 mg. I have to fix that, but this is 2 mg. Throw that 2 in there. All right, so now we need to write our sum of the forces on each of these objects. I'm going to include this summation sign, and just for clarity, I'm going to put a little 1 here and a 2 there. So this is the sum of the forces on object 1. And again, this is just like a placeholder. It doesn't mean anything. It's just notation. And I could certainly write it out in language, or there's other ways I can do it. This is just a way that makes sense to me and is, I think, clear, to whoever the AP rater is, it'll likely be clear what you're doing as well. Okay, so first we're always going to say like, well, what is the net force on this? So we're always going to have like kind of like 2 places. We're going to have this place here, which is where the net goes. So that's going to be whatever your mass is times whatever the acceleration is. And then we're going to have an equal sign, and then we're going to have whatever the forces are, all right, over here. So this is the place where all the forces go. So just to give you an idea. So what is the mass in this case? The mass is equal to 3m. And what acceleration is that 3m experiencing? It's experiencing acceleration a. So that's like your net force. F net is equal to ma net situation right there. And then over here, you're just going to take a look up here and say whatever forces are acting here are the forces that I'm going to write over here. So we have 2 in this case. And we have 3 mg, and we have tension. But I don't know what signs to put in front of it yet because I have not made the determination yet of where this object is going. So I need to do that. This is the larger mass. This is the smaller mass. So presumably it's going to go in the direction of the larger mass. I don't need to know that. Really, I just need to say, like, I'm going to call forces that point this way positive, and I'm going to call forces that point this way negative. So after I have done that, I can throw in these directions, and then this becomes a positive 3 mg, and this tension right here is pointing to the right, so it becomes a negative tension. Okay, and get rid of these things. Okay, so I've done that for this situation, as is true with most of these Atwood type machine scenarios, and I have to write the sum of the forces in the for the other object, and then this allows me to compare the two and kind of do systems of equations type problems. So again, we're going to have these two areas over here. This is the F net, MA net type area. So we're substituting in the mass that we have. What is going on? So that would be 2m in this case, and then the acceleration that it experiences a. And once again, both of these objects experience the same acceleration because they are connected by this string, right? So whatever direction one of them goes, the other has to go in the same direction. Okay. So where are we? Okay, we're right here. 3 mg and tension we have up here, and so now we're looking at this object here, object 2, and that object is going to experience a positive tension because this tension is pointing towards that positive thing that we defined ourselves, and then a negative for the mg. So I'll write it like this, minus 2 mg. From here, we need to solve for one thing and substitute in the other. Because we're trying to find the acceleration, it makes sense to solve for the tension so that we can substitute in tension to the other equation and we still have our A. If we do solve for the acceleration in one of these problems, then that's fine. That'll allow us to find the tension in the string, but then we'd have to go and find the acceleration. So either way, it's easy for me to add this term over to the other side. Then I have a positive tension, which I'll be able to substitute in there. So that's my plan. Now, you don't have to have a plan. You just have to kind of, see what you can do and sort of go for it. This becomes 2ma plus 2mg is equal to that positive tension. So again, I moved this term over to the other side. Now that I've done that, I can substitute in this tension up here, and doing so will allow me to solve for my acceleration, because then I'll only have one unknown. So I'll do that on this next line, and I'll copy that line down. So this next line will be 3ma is equal to 3mg minus, all right? And then, so because we're putting in multiple terms, I like to put parentheses here, so that I don't forget to distribute that negative sign. That's a super common mistake in these situations, right? A lot of times when we get problems wrong mathematically, it's because we've lost a negative sign or done some little algebraic error. So now we distribute that negative sign through in the next line. I tend not to do that in a single step because that's when I find that I myself personally can make those mistakes. You may be different, right? So you may be able to just do it in then one step, because you'll notice right now I am just saying the same thing again. I just have distributed that negative sign, and that's something that's helpful for me. All right, so as we said before, because of the way this problem is situated, it doesn't always have to be this way, but you'll notice that there's a mass in this term, this term, this term, and this term. There's a mass in every term, and we have a mass in each term on opposite sides of the equal sign. So because of that, I can cancel out these masses. If you prefer, you can pull that mass out and then see that you divide each side, but I like this shortcut version, and I understand the algebra, so I do it in this sort of quicker way. So now that we've done that, we have a lighter situation, so a lighter blue, right? No math, get it? Hilarious, okay. So now we can copy that whole next line down. Again, and I keep saying again, I know, but bookkeeping is important here, so keeping track of terms, being nice and neat and organized. I have an A on this side and an A on that side, so I'm going to get them on the same side. So I'm going to add that over, and we have 5a here is equal to, and I can combine these two terms. I have a positive 3 and a negative 2, which means this is equal just to g over on that side, which means when I divide both sides by 5, I get 1/5 g is equal to my acceleration. So that is my answer to number 1. Okay. And I said I was going to solve this more generally. I guess that I didn't exactly, but we'll maybe find we'll move on more quickly on number 2 than we did in this. Okay, so number two is a very similar situation, so I'll move on to that, and here we go. Where is it? Where is it? Where is it? There it is. Okay, so in this particular case, right, 5 here and just an M here, right, meaning we need to find that mass to satisfy this situation. So I'm going to skip the step of putting them in a single plane just for the purposes of moving this video along, but you're welcome to certainly do that. I'm going to solve this algebraically, implicitly first before I put in the explicit numbers in the situation. So I am going to just call each one of these, I'm going to call this M1G down, and I'm going to call this M2G. So just to remind myself, I'm going to put a little 2 right there so that I can keep track of things that I'm doing. And I may even write next to this that this is equal to my acceleration. Again, this is good for raters to see, and it's good just for you, for generalized bookkeeping. Because it's going in this direction, I'm going to call this the positive direction. Right, and I'll put it in a different color for clarity's sake. I think I used black before, so I'll use black here. I'm going to put a positive there, and I'm going to put a negative there. This is now enough for me to recognize that this vector is pointing in a positive direction, and this vector is pointing in a negative direction. If that's not enough for you, then don't do it that way. Right? So this has a vector pulling up of t, and this vector has a vector, this one has a vector pulling up of t as well. All right, so the sum of the forces on block 1, taking a look at what we have going on, again, this first bucket is going to be my M1 times A, which again, I know what M1 is, and I know what A is, so I really know everything that's there, so that's good. And then over here, I have my two things. This M1G, right, is pointing in that negative direction, so I'll throw that one in first. And then this is pointing up and around down towards that positive direction. Again, if you prefer right now or forever to flatten it out, go ahead and do that. Sum of the forces on object 2, similarly speaking, this is M2A is equal to, what do we got? We have a positive M2G, and then we have a negative T. Okay, so this is generalized Atwood for anything right now, which is maybe the way I should have formulated it above and then substituted in, but hindsight is 40/80 or something like that. So what do we need to solve for? Well, we could substitute in numbers right now, but recognizing, let's just take a look at what we have. We have M1, we have A. We have M1, we have G, but we don't know what that tension is. So looking at the other question, we don't know what M2 is. Oops, I want to not highlight that. So we don't know what M2 is. We know what A is. We know what M2, excuse me, again, we don't know what M2 is, but we know what G is. And again, we don't know what that tension is. So we still have the same situation where we have two equations and we have two unknowns. So I still need to solve one of these and then substitute it into the other. Because I am ultimately looking for this mass 2, I want to solve one of these for tension, just like we did above, and then substitute it in order to find that. So I am going to solve this, solve this equation for tension so I can substitute in that tension down here. That's my plan. And no matter what, you'd be able to find one and then substitute it into the other. It just might mean you have to substitute back in if you don't choose correctly. So a plan is good, but not necessary all the time, right? You just got to make sure you keep moving. You don't have to know what the next step, if that's going to be the best version. Just keep moving. All right, so moving that equation here, I'll move it down so we can see the algebra that I'm doing. So I'm taking this equation right here, and then I'm going to move this M1G over to the other side. So it's now going to look like M1A plus M1G is equal to that tension. Now I can take this part of the equation, and I can substitute this business in here for the tension. So that's where that equation is. I'll get rid of that tension, and I'm gonna make some parentheses here. So I'm gonna do a less bad job. And then this portion of it is going to go right in here. Right? So we're substituting that portion in. Right? So hopefully you can see that. Now, like we've done before, except I'm not going to write it another line, I need to distribute that negative sign, which is going to allow me to get rid of this. And in distributing that negative sign, this now becomes a negative as well. Differently than before, instead of solving for my my acceleration, I'm going to be solving for my mass. So I want to get these mass 2's on the same side. So this is now going to look like M2A minus M2G is equal to negative M1A minus M1G. So a little bit different in terms of algebra and algebraic whatever right now, but I can do some stuff. I guess if I wanted to, I can pull out an M2, and this now becomes A minus G. And over here, we have, I can pull out this M1, and this becomes negative M1. I don't need to pull out the negative, but I will. So in pulling out that negative, this becomes A plus G. And dividing both sides by A and G, this becomes M2 is equal to negative M1, A plus G, and A minus G in the denominator. Okay, so that's our generalized equation here. I'll slide this over to the side, and we can put in the numbers now that we actually have. So we have a negative, what do we have? 5 is M1, 5 kilograms. All right, and then our what is happening there? Okay, then our acceleration is going to be 2 plus, I guess I'm leaving off units, but 2 meters per second squared plus the 9.8. I'm just going to call it 10, just to keep this easy for me to manage. And then on the bottom, we're going to have the difference between the two. So it's going to be 2 minus 10. And that's good because if I didn't have this situated in this way, you notice I would be left with this negative out front, which would mean a negative mass, which would be problematic for reality. So in the numerator, we end up with 12 times 5. So we end up with negative 60 in the numerator. And then in the denominator, we end up with negative 8 down here. So those negatives are going to cancel out. And then we just need to determine what 60 divided by, right? So 56 is 7. So then half of that. So this is going to be 7.5. Okay. Is going to be our mass in kilograms. That's going to be what our mass value is. And then all you need to do, if you are curious and want to check your work, is you just need to substitute that back in and see if you get that answer again. So we would take this and we would put it in up here. So I guess I will do that just to make sure I didn't mess anything up. So I will take this, duplicate that, bring it down here. And we'll just test and see whether or not, if we put in all those variables, we get something that's left and right are equal to one another. Okay, so this is 7.5, and we're saying the acceleration is 2. This is 7.5, and we said 10, and then minus. Oh wait, tension. We don't know what that is yet. So I guess we'll find the tension and see if that makes sense. So this would be 15 on this side and 75 on this side, and minus the tension. So then we just need to move that tension over to the other side, or we can imagine just subtracting the 75 and then multiplying by -1. And so we get our tension is equal to 60 newtons right there. Okay. So now to continue this check, we'll take that 60 newtons and see if we still get, if we still get our 2 meters per second. Different ways to do this check, but I know what my M1 is. M1 is 5 kilograms. I'm going to solve for this acceleration, which I expect to be 2 meters per second squared. But we'll, as I said, we'll solve it. So this is -5 kilograms. I guess I'm now including units. 10 meters per second squared plus 60. All right, so we better get those values correct. So this becomes -50 plus that 60 over here, and this is going to be 5a. Put these two things together, we get a positive 10 divided by 5, which lo and behold is equal to our 2 meters per second squared. So, joy of joys, that checks, and there we go. All right, so that's numbers 1, 1, and 2.